Hello, everyone, and thank you for joining us for today's office hours. I'm Haley Matisow, and I'm here with Boris Glazeman, this week's product expert. Throughout the next 20 minutes or so, Boris will be taking you through a live demo on code-free ETL on Hadoop, as well as taking any questions you may have submitted at www.rapidminer.com/office hours. So that's the page that you're currently viewing the office hours on. And after the live demo, again, we'll be addressing your questions. So I just want to go ahead and show you what that looks like and where you can submit your form. So you just have to submit your email, and then you can submit a question through that form there. So why don't I go ahead and turn it over to Boris now.
Thank you, Haley. Hold on one second. Let me just do one little housekeeping. Great. So I'm going to mute my speaker so I can't hear you, and you cannot hear the echo. My name is Boris Glazeman. I am a solution consultant with Rapidminer. Today's topic is code-free ETL for Hadoop. So we're going to do a few things. I'll show you an essential part of Rapidminer platform called Hadoop. Hadoop, in essence, is a platform for executing your process, for building your process, for constructing your process on the Hadoop, completely code-free. Hadoop allows you to visually create your data preparation, in essence, your ETL process, allows you to run your favorite algorithms, and we're providing a variety of algorithms. So we're covering the whole Spark ML library. We have Mahout, we have Pig and Hive scripts. So you will see today a variety of technologies that we use, Hadoop technologies that we use. However, we allow you to use them visually. So you don't have to be writing any Spark script. You don't have to write any scripts of any kind. We will actually generate them for you. You will be presented with a graphical interface and a set of so-called operators, if you're familiar with Rapidminer, that allow you to build your processes. And the processes, in our case, consist of two steps. So one is the ETL. So I need to pre-process my data prior to actually modeling and prior to using algorithms that I will not be talking about today. So that's a second office hour presentation. We will be presenting available algos on Hadoop, and we'll show you how to do your modeling, how to do your machine learning. Today, the topic is preparation of the data. So if you ever build your models, if you ever build your processes, you would know that preparation of the data takes approximately, I would say, 60 to 70, even more, up to 80% of the time, right? So you need to prepare the data, you need to create the data, you need to clean the data, you need to remove missing values, you need to select attributes, et cetera, et cetera. So that process is very time-consuming, and it's super difficult to do with technologies that require the script. So Rapidminer provides you, specifically Hadoop, provides you an extension called Hadoop that allows you to automate this process completely, that hides all the complexities for you. And the second biggest benefit of Hadoop is that we do not retrieve the data. We do not get the data out of Hadoop. So if you have extremely large volumes of data sitting within your cluster, we do not get it out to your workstation to do your modeling or to do your preparation. We actually will generate scripts, again, depending on technologies, depending on the operator that you're going to use. And you will see a variety of operators that use different technologies. We will generate scripts. They're going to run on the cluster itself, and we're only going to get the results back. So you don't have to pretty much be limited by volume of data. So we can work with unlimited amount of data. It's just limited by the capacity of your cluster to process all of the scripts and handle all of the data. We're only going to get the result back, which is an extremely intelligent way of working. I am going to share my screen. in 1 second. So I am going to share the entire screen. Oops. Let's try it again. I don't know why it does that. I am going to then share one at a time, so hopefully that's going to be easier. So you should see my Rapidminer Studio with the marketplace. If you don't know how to get to the marketplace, marketplace is on the extensions. So if I go into marketplace and I will look for something called Hadoop. Hadoop is an extension, but it's an essential part of Rapidminer platform. You will see this Rapidminer Hadoop version 7. It's a recent release. We're actually coming up with a new release shortly, but this release is quite recent, a couple of months old. You would install it as you always would, your extensions. You'll have to restart the studio, and you're going to have Hadoop available under the under extensions. So you have additional 72 operators under Hadoop. All of these operators are using technologies that are, so actually you can see what technologies they're using. So we're using Hive to retrieve the data, store the data. We're using different modeling techniques. So for predictive analytics, logistic regression, for example, has an icon of Spark. So we're using Spark ML Libs. For segmentation, we use Mahout. Right? So different technologies, different Hadoop technologies are being used for different purposes. Anything that will do. Right, so first thing first. So first thing you need to do is you need to define your connector, right? So you need to connect to the data source. So I have two instances. I have a little sandbox, Hortonworks sandbox, and Cloudera CDH 5.5 sitting here accessible. So I can show you actually access to both of them. Maybe I can start from blank page. So this is the way. This is where I would define my connectors. You can actually get to the connectors on top. But this is my, for example, Hortonworks connector. So if I click on the right, and I'll show you different options on how to create the connector. So, right. So my connectors are here. So I'm going to manage my connector, and I have my Hortonworks. So I need to define a connector. So I'm setting my master node. So either by name or by IP address. I can select the Hadoop version. We support pretty much anything out there. So you can see your Clouderas, you can see your Hortonworks, you can see your Amazon, your MapAirs, etc. We have a set of advanced parameters. We have a set of advanced parameters, so you can take a look again. Additional libraries that you need to pass. If you have multiple masters, you can just specify the master, node names, resource managers, Hive server address, etc., etc. We can change the port names if you change your default port names. You can set up different SQL settings. So this is very important. It just depends on your flavor of SQL. So you can do Impala, for example, connect via Impala, which is going to give you a bit less of the less operators, because Hive just has a bigger set of operators that you can use, bigger set of functions that you can use. But you can use your Hive different versions. You can use your security settings. So we fully support. If I can enable security, we fully support Kerberos, so you can supply your key tabs in the upcoming release that's coming out in a couple of weeks. We'll be able to supply a username and password instead of key tabs for your Kerberos. You can supply variety of parameters. You can see I don't have to read them all. So we fully support Sentry, all kind of pretty much anything that's out there on the market, right? Spark. So starting with version 1.5, we started supporting R on Spark and Python on Spark. So depending on your specific implementation, you can specify what version of Spark you're using. You can specify additional Spark libraries. You can specify additional parameters as you need it. So, for example, here's my Spark parameters that I need to specify additional Hadoop parameters. So, in terms of key name value pair, some advanced Hive parameters, etc., etc. So, just to make the long story short, we pretty much support anything you can imagine in terms of Hadoop. This is, again, one of our strongest, probably one of our biggest differentiators, our ability to connect and our ability to connect securely to your cluster, ability to generate scripts and run them on the cluster and just get the results back in a completely visual, interactive format, right? So I have my little Hortonwork HTTP 2.3 sitting there, which I'm going to select. I will test the connection. It's very important that you do test this connection. So you can see actually the steps we're running through. This is a short test. We can also do a full test. But even with a short test, we will try to run through all of the technologies that we require. So you can see test 1 of 10 is a Hive connection. Test number 2 was fetch dynamic settings, etc., etc. So we will test access to HDFS, access to MapReduce, etc., etc. So in other words, it's not just a test to see if you're connected or not, but we will see all of your technologies, all of the technologies that we will use in building your processes against Hadoop. But don't forget, the full test is very, very important because that is actually going to do even more exhaustive test. It takes a little bit of time, and we'll warn you that it may take a couple of minutes, but it's truly, truly going to go into Spark, and it's going to run some Spark ML lib scripts to see how well you configured your connection, or how well your cluster is configured. So back into this Hadoop data. So we can have, execute query will open this little window where you can just copy and paste. So if I take my little, Hive SQL query, I can just copy paste it into this window and then do my, there you go. So it just came up. So my apologies. So I can just do my, I'll copy paste, I'll cheat. So I'll create a table using HSQL. So just drop the table, create a table, load it in path. So I'll show you that I have actually a little CSV file sitting out there on the on HDFS is going to load it in. So this is another facility that you can work. Clearly, this is not code free, and this is not the topic of today's discussion. But we have this facility to pre-process the data, and you get access to HDFS. You can access to Hive via your Hive connector, right? So this is just a quick way of doing whatever you need. But this is not only limited this is not only DDL where you can create and drop the tables, but you can do whatever you need to submit the queries. Not very exciting, simply because it requires coding, right? What is more interesting, so I'm going to close this, all of it, and I'm going to go back to design mode. If you're familiar with Rapidminer Studio, this is a design mode, so you can see the blank canvas where I can start manipulating the, building my ETL process to manipulate Hadoop, right? So the first thing I'd like to show you is a very, very simple, example of getting the data out or getting the data into the cluster, right? Under Hadoop 72 operators, you have the most important operator called Hadoop Nest. So Hadoop Nest is the main operator. It's a composite operator. You can see it has a little blue icon on the right bottom, which means anything that happens, so you can double click on it and place operators within it. But this operator is super important because anything that happens within this operator will actually happen on a cluster. We will not, unless we want to, we will not necessarily retrieve the data out of this operator, but we're only going to get the results back, right? So I can place my data preparation, data manipulation, data blending, data cleansing, my modeling operators within this operator. All I have to do is just connect, and it's going to get executed on the on the cluster itself. So I'm going to connect to my, I'm sorry, resolution is really slow, but this is my Cloudera CDH 5.5, a little VM that's sitting there. It's not very large, but nevertheless. So if I double click on this operator, I can just set a number of operators that I'd like to use. So let's take a look what we have. We have, for example, data access operators, right? So if I drop an operator called retrieve from Hive, I'll connect. The outputs, it'll propose, you know, so this is a metadata. So it shows you all of the tables that exist on Hive, right? So I can refresh it. I can select, okay, so get me a table called flights, or flight, right? I can add additional workflows. So this is not an override to your HSQL, but this is actually a workload. So you cannot put a DDL in it, but you can put the workloads that you need to. And all I have to do is run it. So everything now will happen. On a cluster, we're going to get the data back simply because we said now at the end get the data back. But typically, we will not do that, but we will put a sequence of operators following that. So we'll do something to the data. I will transform the data prior to analysis. And everything will happen on the server, on the Hadoop cluster. If you're not familiar with Rapidminer Studio, this is the result view. So we're showing you the structure. So we just got this data out of flight data out of our Cloudera CDH 5.5. So you can see the columns that are there. There's a basic flight information, so flight numbers, origin, destination, distance, day of the week, when they flew, etc. You can take a look at the this tab. This is a statistical view. So if I like take a look at, for example, flight numbers, then I can see, take a look at it at the visual format. Right? There's a basic statistics that's given, minimum value, maximum value, average, deviation. If it's a numeric, in this case, it's a real. I can open the chart and I can show you, you know, we have a variety of visualizations. Again, this is not a data visualization platform by any means. This is more of you know, visualization for you to analyze the data prior to modeling, prior to analytics, prior to advanced analytics. So I can take a look at my data in a variety of formats and scatter plots and plot something, you know, month and versus flight numbers or something, right? So this is very, very useful to look at your data. We can even have three-dimensional charts that, again, not meant as a data visualization platform for the end user, but it meant for you to analyze the data prior to doing something with it. In this case, we're doing ETL, but normally you would do modeling, right? So this is a very, very basic, just get the data out, right? I can actually do a couple of things. Let's take a look what else is available in terms of ETL for Hive. We can do read CSV. Why would you do that in Hive? Because this operator actually shows you on the right, if you're not familiar with Rapidminer, on the right bottom, we give you a little description of every operator. So it actually tells you that this is very similar to built-in read CSV operator. However, it's not going to read the data into memory, right? It's going to read it directly into Hive, which means you can work with extremely large volumes of data. So we don't occupy the memory. We have the same operator. If I take a look at all the available operators, this is now native read CSV operator. However, this one, I can use it, not an issue. Let me do this actually. I can use this read CSV operator, right? So this is not within my Hadoop Nest operator, so it's going to be executed locally, and it's going to be read into the memory of the of this machine. Right? I can still use it. I can still build a process based on that. Not an issue. So I can go through a regular, you know, wizard with that operator. I can get the flight data. Right. So here's my flight data. This is our regular import CSV operator that's going to go through the CSV file. You can tell it, you know, what format, what delimiters to use, pass it to Hadoop Nest, and then I can just create, let's say I'd like to create a table within Hadoop. I can still use my Hadoop Nest instead of retrieving the data. Maybe I'd like to go back into Hadoop, and maybe I'd like to create a table, right? So I can do read or write a table, right? Well, I'm sorry, I can go into create this table, right? So I can store it in Hive, right? So the data that I just read from a CSV file, and I'm just showing you the difference, this one is going to store it somewhere in Hive, right? So this store operator, I'm going to show you the results. if I connect the ands. So this store operator will need a table name. So it's a Hive SQL table name. I'm going to specify drop first because it already exists. You just saw it a second ago when I pulled the read Hive. So I'm dropping it first. We can also do external tables. So you can keep the file in the HDFS if you'd like, right? They can do partitioning, so it allows you, so it understands the metadata of the CSV file that I just passed. So you can do the partitioning, you can do custom storage, etc., etc. I'm going to do very, very simply, and just to demonstrate the difference between read from the CSV from Hadoop extensions and read CSV from native extensions. So all I'm doing here is I'm reading externally, right, outside of Nest, so it happens locally, and I'm going to store it back in Hive. There's no magic here. And if I run this process, you will see in a second nothing will actually, well, you'll see the table. So here's the table structure, right? So they created a table out there, right? Dropping it first because there was a table called flight already in Hive, and they dropped this table and created a new one, right? But it read the data locally from my local file system and loaded in the memory prior to creating this table. If I use read CSV operator or read database operator, so you can read it out of another database and create a Hive table, I can read the CSV operator. I'll need to place it within Hadoop Nest. Remember what I said? Everything that happens here will happen on the cluster itself. We will not retrieve this data, right? We will not retrieve this data prior to storing it in Hive. So everything will generate the script, and which script is this Hive script, and we will place it in Hive without having to retrieve. And only the results, if I choose to, if I disconnect, for example, this output, I won't even have to have a result back. So everything will happen. Imagine really large quantity of data. Well, everything will happen on the cluster itself, right? So it has a little wizard, very similar, except it allows you to do a couple of things. You can get it out of HDFS, right? Or Amazon if you're using Amazon storage, or local file system, or HDFS, right? So here I can actually take a look at HDFS, what I have in there, and I believe I have something in. I just got to remember where it is. No, probably it was in users. Somewhere there was a file, so I can get it out of, if I remember. So let's take a look at, there you go. So this is my Cloudera. This is my hue. And if I take a look at where I am, just to remember where the files are, otherwise I'll have to just navigate and search for it. Right, so my file is somewhere, right? So the idea is I can just get the file. I could have sworn I wrote it down somewhere. I can get a file out of HDFS, or I can get a file out of my file system, right? So if I cancel, if I go back and show you the difference, so you just get it out of a local system, which is simply because I remember where it is. My apologies, I'll remember by the end where the file is. So I can get out of my very similar type of wizard. So I specify it's a semicolon delimited, and I'm done, right? So now, you know, I can create a permanent table. I can drop the existing table. I can call it flight. Again, my apologies, but I can do this out of HDFS or a local system. If I run this, everything will happen. Everything will happen on the, maybe I should not be dropping this first. Everything will happen on the cluster itself. We'll come back to it in a second. We'll remember the location. My apologies. Right? So this is an example of us using store the table within Hive and read the CSV file out of either HDFS or local system, right? What else is interesting? So let me maybe build up this example a little bit further. So I'm going to remove all of these operators. So now I have a table called, you saw me creating a table called flight, right? So I can do a couple of things. We have operators to retrieve from Hive. We saw this one, right? So because I'm within Hadoop Nest, I have access to metadata. So I can take a look at my flight table. I can do a couple of things to prepare the data, so kind of partially an ETL process. So if I take a look at the utilities, we can see what we have in terms of Hive. So I can do, drop tables, rename tables, copy Hive tables. I can do things like data blending. So let's take a look what we have for data blending, changing the roles, renaming, rename by replacing. So typical, data blending preparation, type conversions to different types, selecting certain attributes, not all the attributes, generating attributes. So for some reason, I'd like to generate an attribute. So if I for example, take this attribute, I can connect these two, right? And I'll generate an attribute. It gives me a little attribute expression interface. For this version 7.0, this interface is exactly identical to your standard Rapidminer interface. So I can see my, of creating custom expressions, right? Expressions, Rapidminer expressions. So it gives me access to all of the attributes that are available. So for example, if I take a look at the distance, right? And hopefully one time, not twice. And I'll take a look at some basic arithmetic operators. So I can multiply it by 2, right? For some reason. And I'll call this operator distance times 2. Spell it correctly, will be good. Distance x2, right? I will create another attribute within Hive. Again, nothing is being retrieved down to the client. Everything happens down there, and I'll prove it to you in a second. And I'll show you actually the logs. I'll show you on Bari when I connect to Hortonworks. I'll show you the logs of all the execution. You will see the scripts that were run. So we were not cheating. We're not pulling the data down to the client to process it. Let me do something else. Let me do a type conversion maybe just to demonstrate the features. So I can go and say, okay, I'd like to pull certain attributes so it knows the metadata, right? Got the metadata out of the the Hive table flight that I selected via my Hive connector, my connection. And I'll rename an attribute. So let's say not rename, but change the type of the attribute. So I have something called delay, which is currently an integer. I'll make it a real, right? For example. And finally, what I'm going to do is I'm going to store it back into Hive, right? So I'm going to say, okay, it's not part of data blending, but let's put it back into Hive, right? So I'm going to create another table rather than replacing this one. I'm going to create another table. I'm going to call it flight 2. Right? All that we have, and I'm going to drop the one that that already exists if it does exist, right? And I'm going to show you the results. So just connect the ends, and if I execute this process, you will see the process is running. You will see where we are within the process on the left bottom. So it's storing the this table in Hive, and in a second you will see the results. So you will see that the table exists. There you go. So it's done. It's completed. It created a new column called distance times 2. So you can see the distance and multiplied it by 2. It converted. If you go back to the statistics view, and you find that attribute that we converted, I believe that was called delay, AAR delay. You can see it's real now, right? While it used to be an integer before. Actually, you can tell it's integer values between 67 and 606. There's no decimals, so. But we forced it to be real simply because, we wanted to. Again, the beauty of it is it's all visual. We did not write any scripts. It's all runs on a cluster. Clearly, I have to have rights to access these tables, create the tables. So the beauty of it is we didn't pull the data out, and everything was done in a visual format. What else is interesting that I can show you? Let me switch to Hortonworks, simply because I can show you what is happening actually on the cluster. So I'm going to minimize this, and I'm going to open another view. And if I go to Google Hangout, I can share my screen, hopefully. So let me share this one. Hopefully you can see this. So I have another connector. So I have another instance. This one is Hortonworks. If I expand it, my apologies again for the resolution. So now I'm I'm connecting to HTTP 2.3. So a little Hortonworks sandbox. that is sitting out there that I configured the connection to, passing, the variety of parameters, including Spark. The Spark is installed, I believe it's 1.5, that it's running out there. So I'm going to start, as I showed you before, with Hadoop Nest parameter. Within that, I will show you something else. So we have ability to execute scripts starting with Spark 1.5. They started supporting Python and R, so Spark R and Python Spark, right? So for example, here I can just drop an operator that is within Hadoop called Spark R, right? So take a look. If I search for this operator, Spark, you can see the Spark scripting operator. It's under Hadoop. I can just drop it and I can just copy paste. So my R script directly within this operator. I can specify additional parameters. I can do the same thing for Python. So it's the same, it's the same operator. I just have to select the language that it's going to run on. So it runs against Spark, but in this case, it's going to be Python, right? So basic retrieve, again, little hive icon, multiply, and this is a Spark icon. So we're going to actually use Spark libraries to run, in this case Python, in this case run R, right? So if I were to submit this, you will see the result. It takes a little bit, it takes a couple of seconds, but you will see the results of me running both R and Spark in parallel. So we can, we absolutely give you most of the, I would say 90% of the things that you can do visually, that you don't have to script. However, if you get to the point where you have to have your favorite R script that you need to run on the cluster, or your Python script that you need to run on the cluster, we give you this facility to pass the scripts all the way to your cluster and execute them there, right? So let's take a look actually while it's running, so you can see where we are. So we're doing Spark R right now. So you can see the little running icon it says on the bottom. So let's take a look at, I need to share this, right? So let's take a look at, yeah, I'm not sure if I can share my, maybe I can. So let's take a look at my Hortonworks. So I'll take my, sorry, I don't have to showcase. Let's take a look at my, there you go. So let's take a look at my Hortonworks. So this is my logs of all the execution. So just to prove to you that I'm not, I actually physically have to go there. So I'm not cheating. I'm going to refresh the screen and you will see what is running, right? So you can see this is my user. This is my PySpark, my Spark R SQL that's running out there. Prior to that, I did the same thing. So everything that is happening truly on the cluster without me having to retrieve the data and run Spark script or Spark R script, or my prior to that was my MapReduce jobs, or what have you, my Spark jobs to do the to do the modeling, right? So we truly generating scripts that are executing on the cluster. Let me go back and share. Hopefully you can see. Sorry, I have to switch to sharing. If I attempt to do this, it's going to do this nasty thing. So I don't want to do this. Instead, I will do. Okay.
Boris, you may want to click the green button on your screen.
Google Hangout.
That'll pay for the screen share.
So I'm going to attempt to share again. I'm going back to share screen, and I'm going to show you Rapidminer again. Hopefully you can see it. I'm going to maximize it. So this is the result of me executing the R script and Python script. Again, using our operators, so you can see the result. This is Spark R SQL. So we got the same information, whatever logic was within R and Python that ran, we ran it on the cluster itself. Yeah. So again, the objective here is, if you absolutely positively have to have a script that is running your favorite script that you have to run, we give you the facility to do that. Yeah. Anything else that I can show that's interesting? So just an example, you know, if I go back to my repository, I'll show you some of the examples that we have. Something. So here's an example of telco that I use when I talk to telco people. So here's an example of, again, I start with Hadoop Nest, and I use a bunch of operators to prepare the data. So this is my ETL step, right? So the typical best practice is you break your processes into multiple processes, first being your ETL, and subsequent after that, you're going to do some kind of machine learning, right? So you're going to do your predictive modeling, but based on the data that you already prepared. This way you don't have to go through all of these steps every time you need to rerun your model. So first step is I'm retrieving from Hive, right? So second step, I'm going to select certain attributes. I'm going to replace missing values. Again, you see this is not our native replace missing value operator, but this is a Hive icon operator, which means it comes with Hadoop. So everything, again, will happen on the cluster. I'm going to generate an ID, which is missing. Again, notice the Hive icon. I'm going to split the data into two, so I'm duplicating the data. It's all done, you know, technically it's done on a Hive and temp tables that, by the way, we're cleaning. We don't have to install anything. We're deploying all the libraries, and then we clean up after ourselves. So nothing has to be pre-configured with other technologies. I'm going to continue to generate some attributes. I'm going to set roles. Roles label is what we're trying to predict, right? So this is our target. I'm going to filter some examples. I'm going to remove all the missing values. I'm going to remap binomial. So the whole set of operators exists. Remap binomial means I'm going to specify what is negative in this case is true and what is positive is false. So we have a whole set of operators for you, and I'm going to finally store it back into Hive, right? As a testing data, and this one is going to be stored similar process as training data. So subsequently, I can run my models on the data already pre-processed and stored in Hive itself. So nothing ever came out of Hive other than I just like to see the result. So I connected the ANDs. If I don't connect the ANDs, I'm not even going to return anything back to the studio. But this is the way I do my basic ETL, my basic data preparation prior to modeling. Next step is going to be modeling based on the data that was stored back in Hive. So now I have a table called training, and I have a table called testing, so I can apply my machine learning algos. So I can learn my model. I can train my model based on the testing training data. I can apply it to a testing data to see the results. But this is the best practice. This is how we normally would do our ETL data preparation prior to modeling within Hadoop itself. Again, nothing came back to us unless we ask for it specifically. This way I can work with petabytes of data without having to worry about, you know, how much RAM I have and can I handle this. Chances are I will not be able to handle it. And everything is done in a visual format, so I don't have to write any scripts. Okay, so this is what I wanted to show you. I don't know how we're doing on time, so I'm going to turn my speaker on because it was off. Haley, how are we doing on time?
Boris, if you could turn your sound off, that'd be great. We're almost out of time, but we have a couple questions that came in. So I'll go ahead and ask you those now. So the first one is, does Rapidminer retrieve the data from Hadoop to do the analytics on the client?
Right, so let's see if we don't have a lot of echo this way. I can hear what you're asking me. So Rapidminer, that is one of the two foundation principles. So for Hadoop, we do not retrieve the data, right? We do not retrieve the data to do your machine learning. We do not retrieve the data to do your data pre-processing, your ETL. We will generate scripts. Again, if I go back to Ambari, if I go back to the logs of what I just did on Hortonworks or Cloudera, you will see that everything was generated as a script and was sent over to the cluster. So the answer is no, we do not retrieve the data unless we specifically say, go ahead, get the data out and show me the results.
Great, thanks. It looks like we have one more question that came through. What volume of Hadoop data can Rapidminer handle?
Right. So again, we're not limited by how much data we can handle, simply because we don't retrieve the data. It's kind of related to the previous question. We will generate scripts. So in case of some machine learning algos, it's going to be the Spark or Mahout, or it's going to be a Hive in case of ETL. So we will generate the scripts that we're going to send over to the Hadoop. So it's just limited by the Hadoop capacity for your cluster capacity to process the volumes of data, and usually it is hopefully appropriately scaled and appropriately sized for the amount of data that it handles. So we're not limited by amount of data that you need to pre-process or model.
Great, thanks, Boris. It looks like at this time we don't have any additional questions, but as a reminder, if you do have questions that you'd like to submit, feel free to submit those at rapidminer.com/office hours in the form that I showed you earlier in the session. And again, as a reminder, this session is being recorded and it'll be available on our YouTube channel later today. And so thanks everyone for joining us, and we'll see you next week.